Hi, and welcome to this episode of Beyond the README, where we're going to take a look at Vault response wrapping. Response wrapping is one of my personal favorite features of HashiCorp Vault, but it can be a bit daunting if you're new to using Vault. There are a number of underlying concepts that you need to have a grasp on before you can really start to appreciate how response wrapping works under the hood. In this episode, we're going to peel back the layers of that onion to understand how some of the underlying concepts really work, and then we'll put them together to see how a response wrapped secret comes together in Vault. We'll also look at some of the practical considerations of using Vault response wrapping. Let's get started. First, what is response wrapping? If we take a look at the Vault documentation, it includes this explanation that Vault includes a feature called response wrapping. When requested, Vault can take the response it would have sent to an HTTP client and instead insert it into the cubbyhole of a single-use token, returning that single-use token instead. So that's really what we want to understand. What are all of these concepts? What is the cubbyhole? What's a single-use token? And why does it matter? And why do these things come together to provide us with a response wrapped token? Really, what's going on under the hood when we ask Vault to give us a response wrapped secret? If you want to follow along on your own, you'll need a Vault environment to work in. You can use the Vault CLI locally to spin up a quick development environment, and that's exactly what I'm going to do for this video. Starting up a server in development mode gives you a local server that you can use to play with, and you can authenticate with the root token that's output by the vault server-dev command. And that's really all you need to get started and follow along with this video in general. So let's start building some of these components that I mentioned. The first thing we want to look at is the Cubbyhole secrets engine. So if you've never worked with a Cubbyhole secrets engine, again, if we look at the Vault documentation, it explains that this engine is used to store arbitrary secrets within the configured physical storage for Vault, namespace to a token. In Cubbyhole, paths are scoped per token. No token can access another token's Cubbyhole. When the token expires, the Cubbyhole is destroyed. So again, a lot of things going on here, a lot of concepts that you really need to understand, and we're actually going to take a look at each of these so you really get a good idea of what a Cubbyhole secret is. So there are two key characteristics to that Cubbyhole secrets engine. The first is that access is limited to a single token, and the second is that the secret is destroyed when the token expires. So let's take a look at that. First, I'm just going to generate some random data that we can put inside of the Cubbyhole. So we have some random data here, and I'm going to write this data to my Cubbyhole secrets engine. We'll just put it at a location such as API key, and we'll give that a value, right? And so I can now read back this data. And you can see I get the value back that I would expect, right? Pretty simple. If you've worked with a key value secrets engine in Vault, this should all look pretty familiar. But really, we want to key in on that idea that the Cubbyhole is scoped to a single token. So let me create a new token now. So just by calling Vault token create, I'm creating a new root token since I'm currently logged in using the root token. If I log in with this new token, let's try to read back that data from the Cubbyhole that we just looked at. You can see that no value is found at that location. Again, because that data is scoped to the token that created it. So now if I create another random value, and I store this into the Cubbyhole, I should be able to read that back without any issue. And you can see that I can. So this token is able to read back data that it puts into its Cubbyhole, but even though it's a root token, it can't see any other token's data. So let's log back in with that original root token. Now that I'm logged in with that original root token, let me try to read that Cubbyhole again. And you can see I can still successfully read that Cubbyhole. Notice that the data stored here is the data that we originally put in this token's Cubbyhole. So each token has its own Cubbyhole, and they can have their own keys and values and data stored there. And they can use the same keys as well, because that data is fully namespaced to that particular token. No other token is able to see it. So that takes care of the first characteristic here, that access to a Cubbyhole is limited to a single token. Now let's see what happens when the token expires. So to simulate expiration, I'm just going to grab that token I created earlier. And I'm just going to revoke it. And now that that token's been revoked, the data for that cubbyhole has actually been destroyed. It's no longer possible to get that data back. So that's critical to understand. If you put data in the cubbyhole, it's lost when that token is destroyed. So now we've covered the two key features of the Cubbyhole secrets engine. And this is one of the fundamental concepts that response wrapping is built on. Now let's look at some of the other concepts that response wrapping is built on. And those are limits around token lifetimes. So tokens typically have two limits that we use in Vault. The first you're probably well familiar with, and that's the time to live. So the time to live indicates that a token expires after a certain amount of time, and it's revoked. It can no longer be used. Now you can renew tokens, of course, and there are limits around the renewal, but once that token expires, it is no longer accessible. There are also use limits in Vault. So after a certain number of uses, we can also expire a token. For example, we can define a token that can only be used 5 times. And after that 5th use, that token is revoked. So let's see this in action as well. So what I'm going to do here is create a token with a 1-minute TTL. And once that token's been created, I'll start a little timer over here. And after a minute, we're going to see if that token can still be used. So first what I'll do is I'll log in with this token while we're waiting. And you can see that I have a token duration left of about 47 seconds. And I can run a Vault token lookup against my token and see that that works just fine, and it tells me all the metadata about that token. So let's wait a minute and see what happens. Okay, so it's been about a minute, and now let's see, when I run Vault token lookup, I get an error. So this token is no longer valid. It's been revoked by Vault. So I'm going to go ahead and log back in with that original root token. And now we'll take a look at the other aspect of tokens, and that's the use limit. So let's create a token with a use limit of 1. So now I've created this token and I can only use it once. So let's go ahead and perform some kind of API interaction with this token. And to do this, I'm going to set the Vault token environment variable for one command only. That way I don't have to switch back and forth between tokens. So using this token that I just created, I'm going to list out the secrets engines in Vault. And you can see that works without any problem. But if I try to do it again, you'll see that that token is no longer valid because it only had a single use limit. And you can even see in the logs over on the left in Vault when that token was revoked. Likewise, if we created a token with a use limit of 2, we could grab this token here. And I could use this token twice. And after that second use, obviously the token expires. Now, if you primarily use the Vault CLI, I want to take a minute to show you something that might be a bit confusing. If I create a token with a single use limit, and I log in with that token, you'll see that I'm successfully authenticated, and now if I try to run Vault secrets list, it fails. And you notice over on the left, you should have seen that the token was revoked. So it can seem kind of confusing if you call the Vault login command why that token is revoked, even though it seems like we've only tried to use it once to list out secrets. And that's because what's really happening under the hood when you run Vault login is that Vault makes a request to look up that token. And that request itself counts against that use limit. So just to show you what that looks like, if I run Vault login and I output the curl string, so the API string used for that request, and I specify any token, we can see the path that's being sent to is auth token lookup self. So when you actually log in using a token, the Vault CLI will send a request to that lookup self endpoint, and that counts against the number of times the token has been used. So if you've primarily worked with the CLI, that might be a bit of a confusing aspect and something to keep in mind when you're using use-limited tokens at the command line. So now you can probably see how we can put these concepts together to form response wrapping in Vault. So let's just create a secret to demonstrate this on our own before we actually start using response wrapping. I'm going to log back in with my root token, and I'm going to create a new token with a use limit of 2 and a 5-minute TTL. And now I'm going to grab this token and I'm going to put some data in the Cubbyhole. That data has now been written to the Cubbyhole. Now I can take this token and give it to somebody else entirely, and they can read that data back from the Cubbyhole. To simulate that, I'll just open another terminal window. And I'll drop that token in and call vault kvget Cubbyhole API key. And you can see I can read that data back. But if I try to read it back again, I get a permission denied because the token has now been used twice. Likewise, if that token were to expire after 5 minutes, we'd have the exact same problem. That token would no longer be valid and we'd no longer be able to access that secret. Fundamentally, under the hood, that's how Vault response wrapping works. You actually get back a single-use token from Vault because it handles creating the secret in the Cubbyhole. And it hands you back a token that can only be used one time, and that token has a time limit on it. So let's see what that looks like. I'm going to put a new secret in the key value secret store here. You can see that the dev Vault instance already has this secret store mounted on the secret path. So I'm going to generate some random data again, and I'll put this data into that secret engine. So that data is now in the secrets engine, and I can read that back. When I call that read command, you see I get back the raw value of that secret, right? Makes perfect sense. We're getting that data back from Vault. But let's try this. Let's read that data back with a wrap TTL of 2 minutes. Now when I read that data back, I don't get the actual secret at all. Instead, I get a wrapping token and some metadata about that token, like an accessor, the TTL when it was created, and the wrapping token creation path. We'll come back to some of this other data, but let's just do a lookup using that wrapping accessor. Reading back this accessor, it looks like a normal token. You can see the standard token metadata, such as the policy applied to it, when it was issued, when it expired, and all that information. So really, this is just a kind of a standard token, but it has some special data inside of its Cubbyhole that we're able to unwrap. So if I take and set my Vault token environment variable and call Vault unwrap, you'll see that I get back some data and some metadata about that token. And this is data that was stored in the Cubbyhole of that single-use token. Over on the left, you'll also notice that token was revoked right at the same time that I called Vault unwrap. That's because by reading back that data, we've used that single-use token and it's now been revoked. And you can see here in the data section, we actually have the value from our API key. And this can be a bit difficult to read, so let's do it one more time. And we'll unwrap this token again, but we'll specify JSON output. And so that's a little bit easier for us to read. We can see the value of that secret. So fundamentally, when you ask Vault to give you a wrapped secret, it returns the token back to you instead of the actual secret. That token can then be taken, given to somebody else, given to a process on a machine, and that process can reach out to Vault to unwrap that token, and it will get back the original secret data. And that's really how Vault response wrapping works under the hood. We're fundamentally taking some Vault primitives like TTLs, token use limits, and the Cubbyhole secrets engine, and combining them into this feature called response wrapping. Now, if you take a look at the Vault documentation, it discusses 3 features that response wrapping provides to a secret. And that's cover, malfeasance detection, and time limits on a secret's exposure. So if we look at the documentation, it does a great job of explaining some of these benefits. So cover for a secret is provided because we're not actually sending a secret across the wire. Instead, we're going to transmit this token to somebody. And you can do that across mediums that are maybe not quite as trusted as your main network or your main network boundary is. Response wrapping provides malfeasance detection because a token can only ever be unwrapped once. So if a user or a process receives a token and they attempt to unwrap it and that unwrapping operation fails, they know something's gone wrong. Now, it doesn't necessarily mean that somebody intercepted that token. Maybe the token just expired because the client took too long to read it. But I know that something has happened and that something probably warrants some additional investigation, like inspecting the Vault logs to see if that token was unwrapped. And finally, the exposure lifetime of that underlying secret is limited because that wrapping token has a time to live. So if I send a token to somebody and they never get around to unwrapping it, that token is the only thing that's exposed and it eventually expires and is worthless to a potential attacker. Whereas if I sent them the secret and that lies around on the file system or somewhere else, that might be exposed for a very long time. So when might you use response wrapping? Well, let's consider an application environment where you have a bunch of worker nodes and then some kind of coordinating process. Those worker nodes might be very ephemeral. They might even be spun up in places that you don't necessarily trust, like a customer's environment or somewhere else. And so those workers reach out to the coordinator, and that coordinator obtains the secrets for them. And that coordinating service will have permissions to read the actual secrets from Vault. But instead of reading the secret directly and passing the secret over to the worker, the coordinator can request a wrapped secret, and it will get that token back from Vault and send that token to the worker. That worker doesn't need any permissions in Vault at all. It just needs to be able to reach the API. It can then send that token directly to Vault, have the secret unwrapped, and get that secret back. Again, we're limiting some of the exposure lifetime. We're providing some cover for that secret when it's transmitted, and the worker can have some idea if somebody else read that secret while it was in transit. And that brings us to another important point, and that is verification of a wrapping token. So the Vault documentation is pretty explicit about this. It explains that properly validating a response wrap token is essential. And it's also straightforward, and we're going to see how that works here in a second. First, let's understand why it's critical to validate a token. Now, instead of a coordinating service, let's pretend that I'm a user and I request a wrapped secret from Vault. That wrapped secret is sent to me, but on the way it's intercepted by a man in the middle. That man in the middle unwraps that response, and then it rewraps it in Vault, and it forwards that rewrapped token to me, right? At this point, the man in the middle has access to the secret, but all I'm getting back is still a token. So how do I know if the token I'm receiving is the real token that I should be receiving? And it turns out Vault provides some really great functionality to help with that as well. So let's take a look at it. So first, Vault explains some of the things that we need to check when we validate a token. And the first is if we're a client and we're expecting a token to come back and we don't get one, that might require us to do some further investigation. Again, it doesn't necessarily mean it was intercepted in transit. Maybe there was a network failure or something else that prevented the token from reaching us. But it should key us in that something went wrong and we should investigate that. The next thing we need to do is perform a lookup on the wrapping token to see if it's been unwrapped or if it's expired. If the token's invalid, it doesn't necessarily mean that somebody's intercepted it. Maybe the token took a while to get to us, maybe because of a network delay, or maybe the application itself just had some delay and that token has since expired. But again, we should investigate that cause to see if somebody intercepted that token and based on the Vault logs determine if that token had ever been unwrapped. So that's pretty straightforward. When you create a response wrapping token, Vault provides a special endpoint that we can use to look up that token, and it's an unauthenticated endpoint. So querying that endpoint doesn't have any effect on the token's validity. It doesn't use that single use. So if I get back this token here that I just created, I'm going to perform a lookup against that syswrapping lookup endpoint. By sending a read request to that endpoint, I get back metadata about that token, such as the creation path, the time, and the TTL. The fact that I get a valid response indicates this token is still valid, and I can see when it was created and confirm that it has not been expired. Step 3 is to validate that the creation path matches expectations. So one thing you'll notice here is that the creation path of this token is set to secret data API key, and that matches the location of that secret in Vault originally, right? This is very important. It's important to verify that the path used to create this token matches what we would expect the path to be for the actual underlying secret. And this bears some explanation to understand why. So going back to this man-in-the-middle scenario that I discussed, if this man-in-the-middle rewraps the token, that creation path is actually going to be different than the original creation path for the token. So let's actually take a look at that. So to demonstrate this, let's see what happens when we rewrap data for a token. First, I'm going to get that secret again with a wrap TTL, and I'm just going to grab this token. And once again, I'll look up that wrapping lookup endpoint. Again, my creation path here says it's data API key, secret data API key, exactly what I would expect. Now I'm going to take this token, and I'm going to unwrap it. I'm going to output the data in JSON format, and I'm just going to use JQ to only grab the data portion of this. And I'm going to send it over to /temp/data.json. And you can see I have that data from that secret back along with all of the metadata. So this is the exact data that we would get back from the call to vault unwrap. So now I'm an attacker. Let's say I have this data and I want to rewrap that data. Let's go ahead and rewrap this. So now I'll send a request to the syswrapping wrap endpoint with that data we got back from that first unwrap operation. And you can see I get back another wrapping token now. So that first wrapping token is invalid. We've already used it to unwrap the data. What happens if I take this token and perform a lookup on it? Can you spot the difference? This time, the creation path shows that this was created using the syswrapping wrap endpoint. This is very different from the endpoint used to create the original secret. The original secret was created using the secret data API key endpoint. So if I'm a client and I get back a wrapping token and I look it up and I see it was created using syswrapping wrap, this means something funny is going on. It probably indicates that somebody intercepted that original token, unwrapped the data, they now have access to that secret, rewrapped it, and sent that token to me. So this should definitely trigger alarm bells and you should do an investigation. Finally, and this is pretty self-explanatory, the last validation you perform is unwrapping the token. And if that unwrap operation fails, again, trigger an alert and investigate why. It might be nothing, there might be a completely valid reason for that failure, but you should definitely be concerned if an operation to unwrap a token fails. Thanks for joining me on this episode of Beyond the README. You were able to take a deep look at how vault response wrapping works under the hood and look at the underlying vault concepts and primitives that contribute to enabling response wrapping. If you enjoyed this video, give it a like here on YouTube, subscribe to the channel, and send it to your friends. I really appreciate it. See you next time.